an experiment to find the density of coconut oil, you are provided with the following. One, U-tube mounted onto a vertical frame with appropriate scales. Two, water and sufficient amount of coconut oil. Three, funnels. Part A1. Draw a labeled diagram of the experimental setup, clearly showing the levels of water and the coconut oil column and their common interface. We have to draw the apparatus setup. When drawing apparatus setup, we can draw U-tube, and if this one is water column, we know that density of water is greater than density of coconut oil. Therefore, coconut oil's height from this common interface should be greater than water height. Then we have to mark it. Water, coconut oil, and corresponding coconut oil height is this one. I will get it as HO. And we have to measure the height of the water column from this common interface. I will get it as HW. And we have to mark corresponding scales. We can use two vertical scales like this, or we can paste scale on the U-tube. Then now there are two scales. We have to label it. Then part 2, on the diagram drawn above, marked as H1 and H2, the two measurements that you have to take. H1 and H2. They have given it. Therefore, we have to mark corresponding coconut oil height as H1, water height H2. You can mark water height H1 and coconut oil height H2. Both methods are correct. Then part B, if the density of coconut oil and water are given by D1 and D2 respectively, write down an expression for D1 in terms of D2, H1 and H2. Now they have given coconut oil density D1. Therefore, the best method we have to mark H1 and H2 is H1 as the coconut oil height and H2 as the water height. Then density of coconut oil D1, density of water D2. We know that according to Pascal principle, there is a same pressure at point X and point Y because of in the same fluid and in the same level. Then we can write pressure at X equals pressure at Y. Then we can write pressure at X, atmospheric pressure plus H rho G. When getting H rho G, H1, D1, G. Corresponding height, density and gravitational acceleration. It should be equal to pressure at Y. When getting pressure at Y, we have to write P0 plus H2, D2, G. Now we can cancel out P0 and P0. After that, we can cancel out G and G. Now we have to get the relationship for D1. Then I will subject D1. H2, D2 divided by D1. H1. H2, D2 divided by H1. it is compulsory. We have to subject D2, sorry D1. Then part C1, select the correct procedure out of the following in order to draw the graph in determining D1. Add in more water to the respective arm and add in more coconut oil to the respective arm. If we are adding water to the right hand side, it means this arm, we can't change the coconut oil height because of coconut oil amount is a constant value. But if we are filling coconut oil to the left hand side, we can observe that corresponding water column is increasing because of this common interface is moving downward. Therefore, the proper method to do the practical is adding more coconut oil to the respective arm. Then we can write answer for the C part 1. Adding more coconut oil to the respective arm. Then part 2, give the correct reason for not selecting the other procedure. We can write when filling water, coconut oil height will not be changed because of there is a constant coconut oil volume. Part 2, in such graph, the gradient is found to be 0.87. Determine the density of coconut oil. They have given density of water as 10 to the power 3 kilogram per cubic meter. Then we can get, when drawing the graph, we have to change H1 height. Therefore, we have to get H1 height to the x-axis, H1 to the x-axis and H2 to the y-axis. Therefore, first of all, I will rearrange this equation to draw the graph. We can subject H2 because of it is dependent variable. We are changing H1 and we have to measure corresponding H2. Therefore, we can subject H2. H2 is D1 divided by D2 times H1. It is in the form y equals mx. Then we can get gradient of the graph should be equals to D1 divided by D2. They have given gradient 0.87. Then we can substitute density of water as 1000. They have given it. Then D1 divided by 1000 equals to 0.87. We have to subject D1. Then we can find 870 kilogram per cubic meter. Then next part D. In this experiment, which liquid should be poured into the tube first? Give reasons for your answer. We know that we have to fill water first because of if we are filling coconut oil will move both arms because of we know that coconut oil is floating on water. Then we can write water and we have to write the reason to avoid to move coconut oil to both arms. Then part E, if you want to determine the density of coconut oil with a fractional error 0.1, what should be the minimum height processed by a liquid column? Assume that height of liquid column can be measured with an accuracy of 1 millimeter. They have given a hint. Fractional error of density delta D divided by D equals 2 times fractional error of height of the column. Then we can write fractional error of density delta D over D equals to 2 times fractional error of height measurement. We have not studied in theory part an equation like this. It is given in the question. Now we have to get density. We have to determine the density with the fractional error 0.1. Then fractional error of density is this one. It means least count or maximum error of density divided by density reading. It is 0.1. 2 times. We have to find minimum height processed by liquid column. When getting height, we are using meter ruler. Therefore, minimum reading is 1 millimeter. Least count is 1 millimeter. It means maximum error of height measurement is 1 millimeter. We have to find H value. H is the corresponding minimum suitable height. Then we can find H value 20 millimeters. Then part F, what is the experimental disadvantage of using mercury instead of water in this experiment? If we are using mercury, we know that mercury is a high density liquid. Therefore, we can observe a small height difference for a difference of height of coconut oil. Then we can write mercury has a high density. Therefore, we have to change oil height by a large value to obtain a proper height difference of mercury.